Hi. Hi, Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Syahrul Bashir and I am from product design. Today, I would like to present about the impact of alpha water and velocity in droplet. So, from this project that I have, I need to find the impact of the alpha water and the velocity in the droplet from ball. Okay, so this is the objective from the project, which is to use the CFD method for mesh generation and analysis of a simple real-world engineering problem. And then the second is to investigate a free-falling droplet into a tank. So this is the introduction for the for the project. So the iteration is the overarching goal of all CFD machine methods is to generate a grid of points that will be used to solve the system of partial differential equations that govern fluid behavior in CFD simulations. Given CFD problems, geometric mesh can be quite complex. Max point geometry like tetrahedra, trapezoid, hexagons, etc., can also shift between different regions of the system while having very fine density across the structure. For example, in the image from the that below, we can see the two-dimension and the three-dimension, and the simple 2D mesh and the 3D mesh. And the main goal is to create a point grid that solves the system of partial differential equations that controls the fluid's behavior during the simulations. Because of the intricacy of the geometric mesh for SL problem, different algorithms must be used, which result in the creation of main points that are disparate that throughout two or three dimensions surface. So this the mesh point geometry include the tetra disk system can be challenge the achieving and accurate the representation of the fluid dynamic. So this is the ball droplet, which is using the CAD software to create the geometry like 0.6 meter multiple 0.6 meter and estimate the maximum velocity of the droplet when meshed 90 and 90. So this is the method, which is from the first thing. As you can see that we use for the base to include the mesh with the 90 and then we use to generate the mesh for the second, and then we can get the result of mesh. And secondly, we take for the geometry and we make four different like a droplet refinement, water and water refinement. And then we uh, go to the patch to give alpha water and velocity, and then we get the generate the wall from the result. And as you can see, the result from the number six. And then and then the number eight, we also use a sampling for slice to get the resolution from the result, and we run from the run simulation and set the time, and then we can get finish the result. Okay, from this result, as you can see, from the using the rotor radius, we use the 0.025 meter, and the mesh division is 90 and 90. And as you can see, the result that we get is alpha water is negative 8.41 FTE per 90 minutes. We say the minimum is that, and the maximum is 1.0028. For the velocity is zero minimum, which is 0.864 for maximum. So the discussion that we made is we analyze the effect of the chosen droplet radius mesh propagation and simulation parameters such as alpha water and velocity. In this simulation, scale is most determined with droplet radius, which is 0.025 meter, in order to capture the subtitles of the droplets behavior during fall. Small droplet radius suggests finer detail in the fluid dynamics. And the reasonable by high resolution, the mesh division is 9 plus 90, enable a detailed deception of droplet. The phase fraction or volume fraction of water is simulation and indicated by parameters alpha for water and given range of 8.415 to 100 to 8. So the value near at one decade of the minimum water phase where a value near zero indicate with a small amount water. For velocity droplet, uh, represent by range from 0 to 0.86446 meter per second, while the maximum is 0.0 indicate by dynamic 0.86446 meter per second indicate a dynamic and potential turbulence scenario. A minimum value of 0 indicate droplet at rest. Predicting the droplet design and the effect it will be on the surrounding fluid. Understand the velocity distribution and a more realistic direction is flow ensured by higher mesh. So the imperative to evaluate the computation is well linked to the selected mesh distribution tool. So the conclusion is the droplet radius mesh division although basis of the dynamic droplet that fall freely into the tank using CFD. Then the alpha water and the velocity have been specified cover potential variation increase, which is have been selected enable detail represent the droplet and the result is a simulation should be provided to obtain new understand of the intricate fluid behavior during droplet descents and advancing our knowledge of practical situation where droplet dynamics are important such as industrial application and environmental process. Thank you. That's all from me.